Dear students, let's start lecture number 7 on the topic algorithm, pseudocode and flowchart of the course analysis of algorithm. This is our today's outline. First, we will delve into software development lifecycle or SDLC. Then we will discuss algorithm, pseudocode and flowchart. Then I'll be presenting flowchart symbols, which are used to develop flowcharts. Then I'll be discussing designing algorithm, how we design algorithm for the particular problem. Then I'll be discussing structure programming, and then in structure programming we will be discussing sequence selection and repetition, which are the most important ingredient of structure programming. And then I'll give you assignment based on our today's lecture. Then I'll share a recommended reading at website which I have used in making our today's lecture, and you can explore more. If you want to explore more about this topic, you can also go through those recommended reading at website. Then I'll share contact information using which you can send the assignment, or you can ask question if you have. So software development life cycle. So you have studied this course you have studied software development life cycle or SDLC in software engineering. So the first part of SDLC is requirement specification. So why we need requirement specifications? So understand what the problem is, why this problem, why you want to solve this problem, then what's the solution you should provide, and what are the constraints on that problem. And then analysis, we will be discussing inputs, outputs, formulas and equations which are under analysis. And then we have design. In the design we develop an algorithm. And how we develop algorithm? We develop algorithm using pseudocodes and flowcharts. And then we have implementation, uh, uh, writing the software in a programming language using algorithm. For example, now you have algorithm, and you have to convert that algorithm into a specific language, like using C++ or Java. You will be implementing that algorithm. So you can call algorithm is independent of a language, so you need, this is independent of a language. Like you have studied Java and C++, so they are syntax based languages, but for the algorithm there is no language. This is independent of a language. Then you have testing. In the testing we demonstrate that how we will check the correctness and verification through different techniques like black box and white box. So what you try to do, you try to test the correctness and verification of that problem. And then maintenance and update, removing undetected errors and prepare a documentation of the program. So this is the whole structure of SDLC, that how softwares are developed. So we will be using analysis for checking that which problem is most efficient. So this comes under analysis. And then we will be designing. So our today's topic comes under design phase, where we will be discussing most of the part that how we write a pseudocode and a flowchart. Now, algorithm, pseudocode, and flowchart. We have to understand the differentiation between these three terms, which will be interchangeably. Sometimes you don't know and you use these terms interchangeably, but they are different. So today I'll try to make it clear that first we have algorithm. So algorithm, set of instruction arranged in a specific order. For example, if you want to add two numbers, so what you have to do, that you have to give first number and then the second number, and then you must have a formula to add these two number, and then you will print that number. So this is logical order, which when executed produce the solution for a particular problem. there are two techniques for presenting algorithms. So these are the techniques that how you present your algorithm. So algorithm is a set of instruction in a sequence or in a order fashion. And then if you want to show that, so you have two techniques like pseudocode and flowchart. You can use pseudocode or a flowchart for showing algorithm. Like for the pseudocode, this is a semi-formal English like language with limited vocabulary. The instructions are closer to computer language, but they are independent of a language. This is the most important thing of this pseudocode. You must know that this is independent of a language. Like for example, if you have a Java, you cannot run the code of Java in C++ or in C, because they are specific, language specific. So but algorithm, this is independent. You can convert using any particular language like C++ or Java. Then you have flowchart. Now what the flowchart is a graphical representation of an algorithm consisting of geometrical shapes that are connected by flow lines. I'll show that with demonstration, but this is graphical way of showing the algorithm, because this is normally this is not normally um, uh, considered that graphical way is more appropriate than textual. So that's why this is a textual way and this is the graphical way of showing the of showing algorithms. So these are the graphical symbols. You can see that we have different navigation lines, like this is for the left side, this is for the right side, and then this is going downward, this go upward. This is show the flow lines actually. Then you have this symbol. This is the start, stop, or begin or end symbol you can use in your algorithm. And then you have a processing symbol. This is a processing symbol where the processing is done. And this is input output symbol. This is you may call it as a triangle, and this is angled triangle. Like you can see, this is uh, input output symbol. And then you have a decision symbol, or a input out or a decision. This is a decision symbol where you take decision. And this is connector. For example, if you want to show uh, show algorithm which is longer um, uh, um, vertically, then you and the page is over, then you can use this symbol on a same page to connect your algorithm. And this connector is this symbol is used for showing the algorithm on another page. So this is the connection on the same page, and this is a connection on the other page. Now, designing algorithm. So structure programming in 1966, Baum and Giacomini demonstrated algorithm can be described using only three control structures like sequence, selection, and repetition. These are the three important ingredients of structure programming. Uh, Top-down design, or divide and conquer, splitting a problem into a several simpler subprograms. A major steps solving each individually and then combining solution into one. So if you have a big problem, what you do, that you split the big problem into a small problem, and then solve each small problem separately, and then you then you combine solution into one. This is what we call a divide and conquer. Algorithm for programming get the data, perform the computation, and then display the results. Now, structure programming, there are three controls like sequence, selection, and repetition. So now we will discuss each in detail. Like for example, if you have a sequence structure in a structure programming, so this is series of step or statements that are executed in order in which they are written. Like for example, this is statement number one or a line number one. This is line number two. So the line number one will be executed, and then the control will transfer to the second line, and then it comes to the last line, and this is how program finishes. So this is, we call it as a linear, this is called linear of sequence structure. So you can show, this is the block way that how we show that you have a begin and end, and there these are the lines, or these are the statement, each will be executed uh, in order. Like first will be executed, this statement will be executed first, then it comes to the second, and so on, and then it executes the last one. Now we will take this and write algorithm and flowchart for using this sequence structure. Like write algorithm and draw a flowchart which computes the daily salary of a worker using the formula given below. For example, this is the formula, like salary is calculated by hours multiplied by payment. So you can see this is the, as we know that algorithm, this is algorithm or a pseudocode. You may call it this is a pseudocode. So now begin, now you enter hours, you have to enter hours and payment, because these are the two variables which you have to enter, because for the salary you must know hours and payment. So now then you will read hours and payment, and then they will be multiplied, and then you will get the salary, and then the salary will be printed, and this is how program ends. Now come to flowchart. Here you can see that as we have already seen in the symbols of flowchart, you must understand that which symbol you are using. This is also very important, otherwise you will be in problem. Like for example, here you can see that program is started with this ellipse sign. So this is the program starting symbol. So we have written here begin, and then this is input symbol, where you are asking for the hours and payment, and then read the payment, and this is how the processing will be done. Now you have hours and payment, and then the both will be multiplied, and then this will be stored in salary. This is called processing symbol. And then this is also, as this is input output symbol, so this is how you ask for inputs, and this is how you show your output, and this is how your program ends. So this is the graphical way. So this is a flow chart, and this is the algorithm or a pseudocode. This is independent of a language, you see. Now this is here we have not mentioned that we have written a program in Java or a C++. You can write this program in any language, like you can take it to Python, or you can take this to C++ or a Java, where you want to write. You can convert this journal program into specific program. That's why we call this as a platform independent. Now write down an algorithm and draw a flow chart to convert the distance given in miles to kilometers using the formula. For that you must have a formula. So 1 mile is equal to 1.609 kilometers. So this is how the algorithm or pseudocode is written. So enter mile, and then the mile will be multiplied with 1.6, and this is how it will be converted to kilometer, and then it will be printed. And this is how you show this flow chart. So you have a begin, you have an input symbol where you are asking for the miles you want to convert into kilometers. So you can see there miles, and then you are multiplying miles with given miles with 1.609, and you will converting mile into kilometer. and then this is the output symbol where you are showing kilometers, and this is how program ends. Write down an algorithm and draw a flow chart that will read the two sides of a rectangle and calculate its area. So this is how you can see that this is algorithm. So this is begin and print, enter the width and length. So then you will be reading or scanning width and length, and then you will multiplying width with length, and you will be getting area, and this is how area will be printed, and program reaches end. This is a flow chart. You can see here that begin and you are entering width and length, and this is the processing symbol where they both will be multiplied, and you will be getting area, and this area will be printed using this output symbol you can see, and then this flow chart ends. Example, the root of ax square plus bx plus c are like x1, this is minus b, because you can see here that we normally we have this is root 2. So you can see we have two variables like x1 and x2, minus b, and this is the formula, and x2, and this is the formula, and then d square b square minus 4 is c. This is the algorithm. You can see here that you are asking for, because you have the variable a, b, and c. So you are asking for these values, and then you will be reading, and then you will be calculating square root of as you know, this is b square minus 4ac. This is b square, so b into b minus 4ac, and then x1 will be like minus b plus d divided by 2 multiply a, and x2 will be minus b minus d, because d is already calculated. So now we can easily write plus d and minus d, and divided by 2 here, and then x1 and x2 will be printed. These are how we get the roots of this equation. Similarly, we have the graphical way of this algorithm, like you have enter three variables, and then they will be scanned or input, and then we will be processing this like this formula like b square minus 4ac, and we will be getting d, and then we will be calculating these two roots like x1 and x2, and after we have these two, now we can print these two roots, and we will get the answer of this equation, and this is how we reach end of this flow chart. Now come to the second. These were the example of sequence structure. Now come to the second one, that is called selection structure in a structure programming. This is the second ingredient of structure programming. Now decision structure of pseudocode may be if a structure single alternative decision, like for example, if condition then alternative, and then this condition ends. So you see here, like we have a condition or a decision symbol. So if this condition is true, then it comes to the processing part inside of that block, and if this condition is false, that it falls outside of that block. So this is called a single if structure. Now you can see the example. The condition of grade is less than 50 is a logical expression. If a grade is less than 50 is true. If grade is less than 50, it carries is true branch and prints fail. If grade is less than 50 is false. If the grade is not less than 50, it carries false branch and does no operation. Like you can see here, like if the grade is less than 50 and this is true, then it comes to fail. Otherwise, if this grade is more than 50, then it comes to false. Now this is if then else structure. Like for example, if you have a if condition, then this one, Otherwise this, now both the token will be used, true and false. In the previous example we was only using the token, but there was no false token used. But in this example you can see here, now this condition has true, condition will be checked. If it is true, then this part will be executed, otherwise this alternate part will be used. So I think that you understand this because you have already studied programming languages, so you can easily understand this one, because this is the uh, basic structure of programming languages. Example of if then else structure, you can see if A is greater than B, then print A, else print B. So you see that both the tokens are being used. So if it is true, then it prints A, otherwise it prints B. Now relational operators, like these are the operators which are available, and these are the description that why we use them. Like for example, this is the greater operator, this is less operator. I think you know these, but for the sake of uh, this slide, I'm just explaining all these operators. Like you have a greater than or equal to, less than or equal to, and not equal to. Here you can see the final grade is calculated as the average of 4 marks. Student fails if final grade is less than 50. Write an algorithm and draw a flowchart to determine a student's uh, final grade and indicate whether it is passing or failing. So here, this is the algorithm. You can see first we will ask for the for M1 marks 1, marks 2, and marks 3, and marks 4, and then we will read all these 3, and then we will get the average of these 4, and if the marks is less than 50, then it prints fail, otherwise it prints pass. Similarly, if you come to flowchart, you can see here that this through input symbol, it is asking for uh, asking for the 4 subject marks, and then it will reading those marks, and then the average will be calculated through this processing symbol, and then through this condition symbol, condition will be evaluated, that if this condition is true, then this prints true, other this prints fail. If the condition is false, then it prints pass. So this is example. Write an algorithm that read 2 values, determine the largest value, and print the largest value uh, with an identifying message. So here you can see that print enter value 1 and value 2, because we have to find the largest. So then we will be reading these 2, and then if the value 1 is greater than value 2, then value 1 will be assigned, because value 1 is greater than value 2, then value 1 will be assigned to the maximum, otherwise value 2 will be assigned to the maximum, because we have only 2, you know. So similarly, if you want to use the flow chart, so you have the same, like you will be asking for the two values, and then you will be calculating using this decision symbol, that if value 1 is greater than value 2, then value 1 is maximum, otherwise value 2 will be maximum, and then the result will be printed on the in the screen. This is how this flow chart ends. So this is your today's assignment. Write a pseudocode and flowchart for linear and binary search, because in coming lectures we will be doing the analysis of on the algorithm, so we need linear and binary search there. For the sake of understanding, first we should understand that how we can design algorithms. So there are two means. We have studied this in today's lecture, that you can design algorithm using pseudocode and flowchart. So what I am requesting you, or I am giving you assignment, that write a flowchart, pseudocode and flowchart for linear and binary search, and this is your cutoff date. You can submit your assignment till 21 April, You can submit this assignment through KCMS, or you can WhatsApp me, or you can send me through my email address, which is shown at the bottom of this slide. You can see this email address. These are the recommended reading which I have used in making these slides. You can also go through this lecture. This last one is very important. You can consider this as well, because most of the slides are already available here. So you can explore more about this topic by going through these slides, so that if you have any question, you can resolve. And if you have any question, you can ask me through KCMS, or WhatsApp me, or email me. I'll be more than happy to answer your question. With that, we reach to end of this lecture. Till next lecture, Allah Hafiz.